In assignment 5.2, you're being asked to combine like terms. Now, when we talk about like terms, that means that first of all, terms are anything that is separated by addition and subtraction. So like in this particular case, you'll see that we have 4 terms. And it's those 4 terms that I'm going to look to see if I can combine. I can only combine them by adding and subtracting if they are like terms. Like terms have to have all the same variables in them and the same exponents. The number out front, the coefficient, that can be different, but the variables and the exponents have to be the same. In this particular example, you can see that every single one of those is x to the 7th. And because they are all x to the 7th, I'm going to be able to combine all of them. So I have x to the 7th plus 2x to the 7th. I'm just going to start with this one, and then I'll worry about adding on the others, because if I can add these two, then I can add all the rest. So I have basically here just 1x to the 7th. Remember that that is truly what that means, is that it means 1x to the 7th. We just don't write the 1 in when it's there. And so I have 1x to the 7th, and I'm adding 2 more x to the 7ths. Well, that would give me a grand total of 3x to the 7ths. So notice the variable and the exponent had to be the same because they stay the same. It's a big actual generalization you can make in math, is that any time two things have to be the same, it's because they're going to stay the same. All right, so seeing how we did just that part, then now looking over at the whole problem is going to be a lot easier, because basically we have 1x to the 7th plus 2 plus 5 plus 8. Well, if I then just do 1 plus 2 plus 5 plus 8, that then gives me 16. And so it's going to be 16x to the 7ths. And we're done. That is the answer you would submit for that one. All right, now on to this one. You'll notice that, again, all of the terms have the exact same variable and the exact same exponent. And so because of that, I know that my answer is just going to be something x to the 9th, and it's just a matter of figuring out what the something is. And so I have 2 plus 4 plus 1 plus 7 plus 9, which is 23. So it's 23x to the 9th. So that whole thing with all 5 of those original terms ended up breaking down to just be one term like that. Now on to the next problem. You notice in this case they aren't all exactly the same. We're not starting with all of them being like terms. And so a great thing to do in this sort of a case is to actually mark them in different ways. So like the very first thing I have here is a number that has no variable on it. I cannot combine that with the x to the 8th because the 7 does not have any x's in it, and certainly not x to the power of 8. And so I look for anything else that has no x's in it, and you notice I do have that here with the 5. Notice when I marked it, I included the plus that was in front of it. That helps me remember whether I'm adding the 5 or I'm subtracting the 5. In this case, I am adding it though, so 7 plus 5 is going to give me 12. Next up, my next term here is an x to the 8th. I'm going to choose to circle anything that has an x to the 8th in it. And so I have an x to the 8th there, there, and there. All right, so then the question is, how many x to the 8ths do I actually have here? And I have 1 from this x to the 8th. So there's only 1 x to the 8th there, plus 3 plus 7. That's a grand total of 11 x to the 8ths. So it's going to be plus 11 x to the 8 as my final answer there. So 12 plus 11 x to the 8th. And the final problem on my particular assignment, again, I do have some variation. I have some that are x to the 9, and I have some that are x to the 6. I can only combine them when they have the same exponents. So I'm going to go ahead and box anything that has an x to the 9th in it. So I have one there, I have one there, and I have one back here. So there's 3 of them that have the x to the ninth. I'm just going to add those together. So 7 plus 5 is going to give me 19. So that's 19 x to the ninths. Then I have this 8x to the 6. Well, there is no other x to the 6 that's going to combine with it, so it's just going to stay exactly the same. So that's just going to be plus 8x to the power of 6. And then that is my final answer, and I am done.